This is not necessarily the data warehouse that I work on. I should probably say I don't speak for IBM. I'm just speaking for myself. I don't represent any of their products directly. I work on their security data warehouse. This is a typical large security data warehouse. And what you'll have is, let's see if the laser works. Can you guys see that?
Yeah.
Okay. You're going to have a vast number of typical security feeds. You're going to have firewall someplace. You're going to have vulnerability scan. You're going to have antivirus. There's the firewall, intrusion detection, NetFlow, patch data, health check data, and then you're going to have secondary sets of data that add context to those. You're going to have information about your customer, about their assets, their IPs, their hosts, their processes, their networks. And you're going to have all these different feeds coming in. Information about industries so that you can group things. Information about standard reference data in the industry. You're going to pull all these in. Each one of these feeds will involve a large number of points of failure. When you bring just a single feed in, it won't seem like it's that hard. But once you actually are surrounded by 20 or 50, or perhaps have one of these that you built, let's say firewall, and now you're talking to 100 different syslog servers, you have a huge management and organizational challenge. And that's what this is about. This is not about, data logistics is not about clever algorithms. It's about organization. It's how, if you can organize it such that it won't vary you. That's it's this way. So just a side note on why we have so many different feeds. Okay. So here, for example, we have an image of firewall data off the syslog server. You have some information about the firewall device itself, a source IP and a source port, a destination IP and a destination port, an action, whether the event was, the connection was dropped or whether it was allowed, and a timestamp. That's about all you get. And I have personally watched data scientists spend years of their lives attempting to gather a vast amount of analysis and information out of that meager amount of information. And they come up with almost nothing. It's a huge waste of money. There's little things you can see. You can look for small patterns, okay? Usually, the conclusion of a year's worth of analysis and research on this is just that it's not enough data. We need additional data to add context, but we can still use it when somebody else wants to do some deep digging after they found something someplace else. So, in a big data analytics project, we want to complement this with related reference information. And so that's what you see here. This is what it would look like in a data warehouse now. So now, in addition to the information we have here, we have also added information from all this reference data. We've added black lists of known bad guys, white lists of the known good guys, say Qualys, a vendor that does vulnerability scanning. We add information about assets. Assets in this particular case, we're talking about IP addresses. So we've added patch information, vulnerability information, and other reference data about any given host that we could see in a connection related to. The extra information might be what's the business purpose? What's the criticality of it? How valuable is the data on it? What's the security policy? There's meta events by a SEM. Are we seeing other events triggered from an intrusion detection facility? IP reputation data. Has this IP that's coming in attempting to make a connection been seen out in the wild? Tell me about this network. Is it private? Is it public? About the device. How about what can you tell me about the firewall itself? The ISP. What exact blocks, not just country, but what exact blocks on the internet did that IP address come from? All this information together means, well, now we can do something. The data scientists, I could have spent a whole year and spent $500,000 analyzing this single bit of information and produced nothing. Okay? Could have, in 2 weeks, produced something fascinating with this. This is what the data logistics is about. This is why we have 50 feeds for a security data warehouse. In this case, firewall, which is just one subject area, has 11 feeds of its own. Now, some of these will be shared with some of the other subject areas, but I think you can see that this is how we're going to get to a large amount of data transformation. Because if I've got 7 subject areas and each of them have this many sets of reference data, I got a lot of work to do in moving that data. So not only are there a large number of feeds, but the feeds are unfortunately rather complex. And this gets to a couple of notions. One of the notions is that it turns out that data structures matter. Data structures really matter for performance. Okay, so while we could just dump this data onto the data warehouse or Hadoop cluster or whatever, in reality, some of our users want sub-second response time. Or if not sub-second, they want it in 10 seconds. They don't want it in 2 hours because they have a lot of iterative analysis to do. So we need to figure out ways to transform it so it'll be fast. And that a lot of times means take up less room. So there's a lot of different things we're going to do with this. Additionally, a lot of this data turns out is garbage. There's bad data out there. And so we're going to do a variety of operations, and I'll talk a little bit more about it. What you can see here, though, is basically something akin to an assembly line. There's a number of different stages in the process. For performance reasons, we're typically not using messaging patterns. We're going old school, back to the old mainframe and old Unix and VAX days of batch processing. It turns out it solves a number of things very, very well at these kinds of data volumes. Note that this is just a piece of a simplistic reflection of a single feed. I'm not showing a bunch of other parts that have to be here. The exact file handoffs between processes, how they get moved, how the whole thing gets audited. Once we flesh it all out, this gets pretty big. Unfortunately, one of the challenges in this space is that there is no silver bullet. The problem even defies reduction. So, for example, there's been a lot of great ideas about how to make this a smaller problem. Keep in mind that a lot of big data analytical systems will have more people working on this part of the problem than any other part. So more people that are working on managing the movement of data than handling the data at rest or handling the analysis of the data. So as you can imagine, there's a lot of people asking, well, how can we just de-scope some of this? Can we go lean? And the problem is, unfortunately, there's cost to everything you cut out. One of the first things people ask about is, do we really need to do delta processing? And the answer is, well, you don't have to, but there's a cost. The cost is, if you don't do delta processing, you're going to have an explosion in the volume of data. Or you're just going to keep the most recent copy of a piece of data. We lose functionality. We're losing detail. So on the data warehouse I run today, we have one feed that comes through, about 1 million records. The feed comes through once an hour. It's a big machine that we're getting this data on. It shouldn't be a big deal. 1 million records once an hour, I can load it pretty quickly. But I have a high concurrency requirement. Because of that high concurrency requirement, I'm not using a really fast load utility. I'm using a different load utility that issues SQL statements and transactions. That one logs everything. That means I have 24 million log records I produce every day, which all go to an overtaxed backup server. And the people on the backup server are extremely displeased. Now, it turns out those million records that I load every hour, I'm only going to change about one, an average of 1 change per hour. So if I do delta processing, now my load just unloads that record, that file from the database, copies it at the operating system level. 4 seconds later, it says, you got nothing to do. You're done. No changes made. That's what delta processing can do for you. It also gives you the ability, of course, to track things over time. The next thing people look at is whether or not they can get rid of all the lookups. You know, replacing all these long strings with different IDs that relate to dimensions, which gets to this issue here too. Well, one of the security vendors whose intrusion detection data I pull in has an average record length or row length in their database of 3,000 bytes. When I pull that into our data warehouse, it has an average row length of 50 bytes with very little loss of information. Because I'm not carrying the same information time after time after time. I'm not carrying gigantic, huge host names. I'm replacing things with lookups, and I'm moving things into dimensions. Now that means I have to do more joins. But you know what? For star schema joins, relational databases are actually pretty fast. It's not that big of an issue. The other thing with dimensions is this means, because I have these big dimensions that don't have very many records, I have the luxury of being able to say, if there's any information in the world that my users want to see, if I can add it to a dimension, done, not a problem. If that means my dimensional row is 10,000 bytes, I don't care. It has no bearing on performance. The other thing that people will say that we'll hope that they can do is descope some of the validations. And they'll say, why don't we just put the responsibility for providing accurate data in the hands of a source system. We'll tell them the format we want the data in, and it's their fault if the data doesn't look very good. And that really cuts down on the amount of labor it takes to manage data. You've just outsourced it to the source system. The problem is most of these source systems don't have people with the right skills to be able to do this job. And they're going to send garbage. It is pretty much guaranteed. They won't even think, especially if they're a transactional system, they don't even think they have garbage because they don't look at it the same way that we look at it. They look at it typically one record or one row at a time. And when you look at the data that way, finding bad data is like finding a needle in a haystack. And additionally, if you do find bad data, a lot of times it's obvious. Well, duh. Of course that negative amount is some kind of adjustment. Negative 10 billion, it's probably a special code. But when you're aggregating that minus 10 billion with the rest of the data from that account, you lose the opportunity to reject it because you're grouping it with 10 million other transactions, and it just skews your data. That's how we look at things differently. And that's why the source systems can't find the problems that we find. The other thing that people will say is, why don't we just not standardize? Let's just dump the data in. Well, here's what happens. This means that you shift the burden of being able to figure out how to standardize the data now to the analysts. These are the people who have to go through a lot of iterations. You just slowed those folks down. Okay? So your data analysis slows down, and you just added a huge documentation burden. Worst of all, what do you think is the challenge? You know, if you think about how hard it is for most people to be able to describe exactly what the data looks like and what it means in most of your transactional systems today. Imagine when the analyst is doing time series analysis and says, we've got some codes from 2 years ago that just don't make sense. Well, not only is there no documentation, but the guy who knew the answer to that's gone. It's in your database. You've got no clue. It's unusable data at that point. You may have been telling the rest of the company that you needed that money that you were going to put all their data away for future use. But the reality is, no one can use it. Finally, somebody will say, you know, we can knock out a quick feed in a week. Why, so let's chop out whatever we can. Let's chop out some of this management stuff and again go lean on that. Well, the problem is you get a lot of points of failure. And unless you do things right, you will spend all your time just fixing broken feeds, and you will spend no time adding new features. So unfortunately, it's just not really an option that works for anybody. So this is kind of melodramatic, but there's what I find when I work with big data analytical teams that really know what they're doing, they sometimes lose sleep over this problem. Especially if they took a lot of shortcuts early on. Especially if they had to learn things the hard way. Because they probably never got a chance to go back and fix all the problems. These are people who know that they are one data quality error away from their whole project being canceled. And they don't know when it's going to happen. They don't know if it's going to happen, but they know it certainly could happen. The first kind of nightmare is back to data quality. So data quality has always been identified as one of the top 3 to 5 reasons data warehouse projects are canceled. Okay, if you're doing a financial data warehouse, you have to balance to the penny. You can't fail to account for the smallest thing. If you're doing a compliance data warehouse, you cannot miss or fail to account for a single finding anywhere. And note that in the case of that compliance system that you're pulling data from, the data quality is not even very good. So you really are between a rock and a hard place on that one. Back to the notion that In our world, when we're doing analytics, these problems don't go away. In the transactional world, they just lost data for a day. They got everything back online. Everyone's cool. Well, not okay. Okay, we're going to see this chart for another 10 months. It's going to come down like this. And every time our customer looks at that dashboard, he's going to say, "Yeah, they're not the sharpest tools in the shed." We remind us. So we lose credibility. And if we don't have credibility, what have we got? I mean, people aren't going to trust these numbers. They're going to start wanting more and more reports in order to prove the numbers. And that gets very expensive for us to provide all this kind of information. And there's a lot of productivity that's wasted on this. When somebody is saying, "Hey, I think this is wrong. I think these numbers don't really match. I don't think they make sense." Somebody has to go spend a day digging through and rooting through everything to show and prove, yes, they do make sense, or maybe they don't. So I've seen a lot of projects fail for this reason. I've seen an ambassador to a foreign country threaten to go to the UN over data quality problems. This gets pretty big. The other issue is reliability. With all those failure points, imagine the concept of a mean time between failure. You've got 50 feeds, and you've got, some of these systems are making changes, and they're not telling you in advance. They don't even know that they're making a change at the time they're making it sometimes. You're going to have, across those 50 feeds, say, 25 different big failure points at each one. You're going to have something breaking all the time if you're not careful. You're going to have, and when things are breaking, now you have other issues. You have concepts of cascading failures. You've broken and left some resource locked or otherwise inaccessible or in an inconsistent state. And now all these other feeds that depend on it are also broken. And this is when you get to determine how good your testing was of running out of disk space. Okay? Odds are it's probably not very good. You're probably hoping it's good. But when you have 12 or 15 feeds all break, now you can spend 2 or 3 days putting things back on track. And again, you lose credibility with your users, and you're not spending time adding new features. You're just trying to fix stuff at this point. Another issue is performance. So, and I don't mean query performance in this case. I'm talking about just how fast your system runs. The biggest cost for a project of this type is labor. It's usually 90% labor. So if your processes are taking 7 hours to run instead of 30 minutes, you will oftentimes have people waiting, sitting on their hands for that process to complete. And at that point, you've really optimized for the wrong problem. You might have saved money, but only in the initial iteration. Your big bills come in the maintenance life cycle of the project. And so you do not want really slow feeds. You do not want resources locked for extended periods of time. And you do not want customers angry because they're waiting and they're wondering, why can't you get the data? The data was published yesterday. Why is it still not in the data warehouse? So in the data warehouse I work on right now, we're loading about 300,000 rows per second without breaking a sweat on the server. There's another warehouse I know of, exact same hardware. They load 30 rows a second. They brought in some of the biggest names in that company in order to try to speed things up. And folks have just decided it's not fixable. It's too deeply buried in how they architected the whole thing. They're stuck at 30 rows a second on $250,000 of hardware. The other issue is disorganization. And this happens because the complexity of a system like this sneaks up on us. It's like one of those hairpin curves. It gets tighter as you go around it. And so what ends up happening is we get into a tight bind. I've been affected by this. I'm ashamed to say I contribute to some disorganization sometimes, having to make some tough decisions and trade-offs. But it's something you have to weigh very carefully. It's a lot of technical debt piles up really quickly when you end up with too much inconsistency. And at this point on a data warehouse, you'll see situations where new staff, after a year on the project, still don't understand how things work. Again, these projects are 90% labor. So if you end up here, this is where you end up with 10 people working on data logistics and a budget that's exploding and management that's not very happy. So let's talk a little bit about root causes. What were the things that caused those nightmares? The first one, I think, is magical thinking. This is where people believe in silver bullets. And what ends up happening is there is no product that's going to fix data logistics for you. There's no ETL product, and there's no, and throwing it on Hadoop doesn't fix anything. As we spoke of earlier, it's primarily about organization. And as other people have said before, like organization and naming are some of the hardest things in computer science. So this is hard. One of the ways that we see people get into problems the most frequently is we'll have programmers who might be star programmers. And they've been building transactional systems for 10 years. And they're excellent at it. And so they want to take their accomplishments, wins, and victories over into this space. They know how to do this. They don't know how to do this. Their transactional experience relates to data warehousing like Windows relates to Unix. It's orthogonal. The methods here are so different that when they try to build this with messaging, they find out that their performance isn't okay. It really sucks. Not only is the performance not okay, but now they can't just back up their load files, their batches. They have to run a giant database backup. And now they need twice as much hardware as they're throwing out. And so on, and so on, and so on. So the biggest issue is just a belief that people can buy their way out of this problem. The second issue is nonlinear scalability. It turns out that King Kong could not exist because of the square cube. See, as you grow something bigger, its mass increases faster than the area increases, right? So King Kong's thighs and everything have to be twice the diameter they are. Well, that's kind of like these. Okay, I know this is stretching it. But what ends up happening is, I'm not talking about performance scalability. I'm talking about organizational scalability. So as these systems get bigger and bigger, their interdependencies grow. Okay, we have more cascading problems that take out 10 feeds all at once. And we have more tough choices and with the interdependencies, so it's harder to modify one library or API because it's so widely used. So what I find oftentimes is that a team will build a single ETL feed and say, well, that wasn't that hard. That's not bad. Let's just multiply that effort by 50. That's not how this works. Okay, so that's one of the issues, is that this effort takes increasingly more and more time as it gets bigger. The other issue that we have here are teams that either try to be too consistent or too adaptable. You really have to have consistency. It's what helps you fight off the disorganization. But you can't be a Nazi about it. If you lecture your users on exactly how they have to provide everything, you run into problems like a data feed on an AS400 or a mainframe, or the fact that you're getting some streaming data in Java. And even though you've done something in Python, this piece must be in Java, that piece must be in Fortran, and this piece must be on some other network, and it can't talk to your network. And it's going to ship the data, it has to come over SSH or via physical medium. Efforts to try to destroy that kind of variability usually end poorly because you don't have a choice, because a lot of the source systems don't really care if you have their data. In fact, I would say it's unusual in a big data analytical project for every one of the source systems to actually wish you well. Usually there's a couple of systems that want to see you fail because they want to do what you're doing, or they don't want you seeing their data. So if you don't have the ability to be adaptable, that makes it really easy for them to not give you data. So the corporate world has an answer to this, and it's called ETL. And as I said before, this comes from data warehousing, and this goes back about 20 years. It's not as well known as it should be in the big data space because big data comes so much more from academia and open source. But it's becoming more and more well known, especially now that we have some open source ETL products like Talon and Pentaho. Let's see, back to our batch pipeline. In the ETL world, and there's different variations. There's ETL, there's ELT. Really, we group it all under ETL because usually most of the efforts to come up with different acronyms are just vendors trying to differentiate themselves. So ETL, extract, transform, load. It's all about batch processing, okay? Not to say that there's not room on occasion for messaging or other methods, that there's not the possibilities of an enterprise service bus feeding data at times. Of course there is, all those things, back to being adaptable. If it makes sense, use it. But when you have 50 feeds to build, then having something consistent and batch-oriented is what's been proven to work the best. Okay? Now, what we have here, in this particular case, there's a lot of different ways of doing it. A lot of ETL tools are driven from a diagram. But that's, of course, not a necessity. In some of those tools, there is not a distinct batch step at each, the commodity interface of a simple tarball in between each step. So that's optional and not necessarily consistently supported by vendors. In the diagram, so this is what a simple diagram looks like for an ETL feed. An ETL feed doesn't have to be complicated. Sometimes your data is perfect and exactly what you need. You just need to pick it up and load it. It doesn't happen that often, but sometimes it does. So here's a mostly illegible diagram of a very simplistic ETL feed. And management loves this stuff. They loved it from the very beginning, when this was first pitched as a productivity tool. So back in the early 90s, when the ETL vendors were selling these solutions, they told folks, this is going to get you out of the high cost of data logistics, because programmers will be faster using this. And at first, the programmers kind of like it. The managers liked it a lot. The meta group in the late 90s discovered, actually, wait a second, COBOL programmers are faster than users of any of the ETL tools. So the productivity claims didn't really pan out. But at first, people kind of like it. Until, they inevitably overdo it, right? Because it turns out that maybe 80% of our feeds are nice and simple, but that last 20% becomes a nightmare when you're using some kind of a diagram-driven case tool. And so, not everything's fabulous about ETL. So ETL is a method, it's mature, but there's not enough general best practices written about it. And that's because since the very beginning, people like Bill Linden said you have to have the ETL tool. You have to buy it. He also sold ETL tools, which is a bit of a conflict of interest. But anyway, so what's happened is this is a space, ETL, that's really been driven by the vendors. It's not been driven out of computer science. It's not been driven out of IT. Okay? And so what ends up happening then is it's kind of lagging behind. This is, when case tools were all the rage in the late 80s, people are looking to just generate all the code. This is one of the few places left where people are just trying to generate all the code. Let's look real quick at the difference in the features. So because it's not 1992 anymore, we don't have to write this in COBOL or C. We have a lot of great languages to choose from. Unit test harnesses, one of the best things that's really, really caught on in the last 10 years. And you can totally take advantage of tightening up a lot of your code through test harnesses if you write it yourself. Not true with ETL tools. You want to go all the way to test-driven development. Again, you can do that. You can have your data logistics team use the same methods that the rest of your programmers use. Again, version control, same thing. You can have a lot more concurrency. You can check out pieces. You have all the benefits of a rich modern tool like Git. Static code analysis. Again, that disorganization that we showed on the prior slide, that's the kind of thing that most ETL tools don't have a lot of methods of detecting or scoring or measuring or alerting you to. We've got plenty of tools for most of our languages. We're seeing these days a big movement is in deployment and automating a lot of deployment functions. Again, we've got a lot of great stuff happening, a lot of exciting things happening in the custom code space, not so much in ETL. A lot of times what we find in the, when we write a project, as much as we'd like to pick one language or one tool, all of our options kind of disappear when we bump into that one source we have to get, and it's on some crazy antiquated machine. Or there's already a client written in some other language. If you write your own solution, you have the flexibility to take that in stride. In the ETL space, you don't always have that option. You lose the ability to talk to a lot of your infrastructure, and you may not have the skills if you focus on ETL tools in order to be able to handle a lot of custom code. The best programmers oftentimes don't like working on the tools. We have continuous integration. We can constantly test things every hour of the day. Virtual environments, and ETL tools provide better diagrams. They provide better diagrams because for the most part they have active metadata. The metadata you type in, that drives the process. So when it creates a diagram, you can trust it. It's accurate. And that's cool. But here's the deal. Most of these ETL feeds, they might take you 8 or 16 hours of analysis. It might take you 8 or 16 hours of development, another 8 or 16 hours of testing. The diagram's only an hour. It's not a big deal. We make diagrams all the time. It's not hard. So it comes down to, for many groups, whether you're going to build or buy. And it's not, and although I've been criticizing ETL tools a bit here, there's a place for them. Very large organizations that don't have a strong programmer culture, that have a large number of simple feeds, really are best off with an ETL tool. Groups where you don't know who's going to come after you, and you don't feel confident in their skills, that ETL tool kind of exerts some constraints, and that can help them out. It provides a framework. But we have a paradox, and that paradox is that ETL tools only do about 80% of the work. And since programmers don't like to work with them, generally speaking, you're kind of hosed on that last 40%. So what I'm getting to then is that there is no great answer. If you go with custom code, you have to have more of a programmer culture. You have to have people who are willing to learn. You have to have people who are comfortable writing code. The notion that you can just be a data analyst and you can do all your own ETL is one that's not really worked well for people. Having said that, if you're in a big Fortune 100, you're building a corporate data warehouse, and you got 400 feeds queued up, you probably ought to get an ETL tool and a big staff. So here's where Python fits in. Python, and my apologies to the Ruby folks out there, because I know you guys see this. I know you guys see this cartoon far too often. Ruby would work just as well as Python almost, I think. And I know people who are doing data logistics with Ruby just fine. Where Python really takes off and has an edge over a language like Ruby is that it's really becoming one of the premier languages for data analysis. So now if your team can do both data analysis and systems management and ETL with the same language, you get some efficiencies. There's some serious benefits to be had there. And so that's why I would recommend Python as the first language to look at for something like this. It's high level, as I'm going to show you, easy to read. It allows you to take advantage of all the best things that are coming out of the programmer space in the last 10 years. And it's a language for enthusiasts. Now this is becoming more popular. Maybe this is less so than it was 5-6 years ago. But importantly, it's also fun. I really like my team to be able to go home and enjoy thinking about a programming problem, as opposed to clocking out the second they get a chance to because they hate working with it too long. So here's kind of a build list. Let's say we were to take that same flow we showed earlier, this time using Python. And my apologies for the garish colors. So what we have here is, you see, now we're talking about, I kind of changed some of the names so it looks like a security feed. We're looking at firewall data. Okay, we have an extract program and a transform. Okay, and then we have a couple of utilities. I have to write these utilities. They have to be written one time, but then I can reuse them. After that, it's the extract and transform I have to rewrite for every single feed. And so when we look at what we're going to need here, we have a number of services. We need metadata, ways of moving data around, some data validation stuff, some things to do file image deltas, publish and load data, and then we just need programs. These aren't really necessarily hard programs. We're going to need a lot of them. Every feed is going to need at least an extract, maybe an extract and a transform. There's going to be configs. It's not that hard. The analysis and the testing is hard, but the actual coding is not that hard. So If I'm using Python, one of the things I want to show you is that I don't really need any of the. I can go with a pretty vanilla Python environment. In fact, recently I was running some of this on an AI Xbox just using Python 2.3.4 up until a year ago. It was pretty stripped down, and it was fine. It worked just fine. So if you're not familiar with Python, what we have here is some standard library stuff. You're going to be talking to the operating system all the time, in my world and how this is done. And CSV files show up more in JSON still, they work fine. Allow logging, unit testing, I hope. Collections is a great way to do aggregations. Command line argument parsing, and some handy miscellaneous modules. It's all standard stuff, comes with Python, real generic. Anyone who's working with Python is probably going to use these. A lot of third-party modules. Again, mostly for just interacting with your environment in a batch way. Talking to web services, talking to the submitting sub-processes, running in virtual environments. Pretty standard stuff, all free. Matter of fact, I think probably every one of these you can just type pip install whatever, and they'll all install right in your environment. In our environment, whatever version control system you want to work with, you don't have to export metadata out in an XML format, put that into ClearCase, and monkey around with that kind of stuff, or interact with a very complex metadata versioning system. It's just programming code. Deployments can be highly automated. Single button deployments are now possible. We can check for outrageously horrific code. We have some great test environments. Testing is one of the toughest parts here because a lot of the sources you're going to be pulling from, they don't have good documentation. So every time you can run a round of tests, you don't know what you're going to get for the next file. Something probably that the source owners aren't even aware that they're producing, or some combination. And so you can do continuous testing, not a problem. Documentation, I'll show you some things there. The bottom line here is we didn't actually have to use anything like pandas. We don't have to use SciPy, we don't have to use tablog, just pretty basic Python will get us all the way there. Not to say that we couldn't use some of these cool things, but there's not a big need for it. So let's talk through a couple of these different components. The first one we get to is scheduling. When we're in the batch world, again, this is your father's computer world. Okay, we're not talking about something new that's GUI driven. We might be talking about event driven versus temporally driven schedules. Okay, so typically what I'll do in a data warehouse environment is we're going to use cron, and we're going to schedule processes to run at highly frequent intervals. We'll have them automatically check to see if they're out there, just using a simple pip command, standard technique, and they will check to see if there's a file ready to process. They're basically running and pulling. This is a poor man's DB. It works really well, and anybody can write this code very, very quickly. Almost no effort needed to do this. One of the things we might do is we might add a library so that we can just touch a file through that will suppress the schedule, and without really altering cron tab. And of course, these days, we're going to say, well, we want cron tab to be part of that automated deployment too. So everything, all of our configs, everything's elegantly and automatically deployed. Another piece that we need to have in any solution of this type is we need something for auditing, okay? Because we have a lot of stuff running. And sometimes we'll see some very complicated and sophisticated issues. We'll hear complaints that sometimes a given process runs slowly. And we're not really sure what's going on there. There's a lot of things running at the same time. We need this audit system to tell us, how's that pattern working out? What else tends to be running at that same time? I was just dealing with a nightmare of a problem of this type where I have a load that normally takes 4 seconds, take 2 hours. Okay, and we tracked it down, and we finally figured out that a backup server that we're pushing our logs to and our backups to is over capacity. So it's just sitting there. Meanwhile, everything's backing up. Now, the whole process generally was still working okay, even though it's supposed to run in 4 seconds. It took 2 hours. Finally, some of the process broke. Then we dug into it, and then we were able to look at all the trending data and be able to say, here's the pattern. We know exactly what's going on. So with this many moving parts, this is some really important stuff. And this is one of the things that ETL tools do really well. This auditing is important. It's not logging. It's not just dumping all of our logs and mostly kind of free-flowing text into a bunch of files we can grep through. We need something much more powerful than that. We need a dashboard. I really like my manager to be able to look online and say, yes, everything is working. It's valuable. Alerts. We need that. And this could be weeks. It depends on the staff. It's not necessarily anything terribly complicated. We're talking half dozen tables in a relational database, not tons of data, simple API, simple dashboard. You might go back to it and iterate through and make it better over time. The next piece to work on is the file transporter. So we can just have everything talk to a network attached drive and just have all the files feel local. But there are some benefits to just pushing the files from process to process and stage to stage and machine to machine. And one of the benefits happens when you totally crater a box. And you realize that, well, your audit system will tell you how what state everything was in. And you have all the files you need on either end of that box that cratered. So now you can put up a new box there, or rebuild that machine, and you can just redeploy from the surrounding files. It can be more complicated than that. I'm guilty of oversimplifying. But I've had to do exactly that numerous times. And so I really like having multiple copies of my files. I like it a lot. Once a year, when somehow I get a file corrupted, and I find, hey, back on that machine, it's still good. So there's a number of reasons why I like this, or a human error. I had somebody delete 3 months worth of data accidentally recently. Having multiple copies is fantastic. This is not anything complicated. This is kind of like a specialized version of rsync. And in fact, nobody should have to build this. The difference is, unlike rsync, which will mirror directories, in this case, you really want pre and post action on both sides. You really want to be able to say, okay, I moved this file to its destination, now rename the source. Because I don't want to mirror, I want to move the file. So rsync doesn't quite do it, and I've dug around a lot, and I haven't found a utility that does. So we keep having to write our own in every project I'm on, and it takes a week to 2 weeks. And it's not that bad. Oh, let me mention, when we're moving those files, so this is a process. It's moving the files over SSH. It's connecting with keys. It's logging everything it does. It automatically handles if anything fails. If it has a network outage, if the DNS server goes down, that's fine. It will pick up again later. As soon as things are reconnected, it will keep moving those files. You don't want to have to deal with that kind of recovery and that kind of retries in all your applications. Our goal with those 50 feeds is to keep those 50 feeds simple. And so we want to make it so you don't have to write any of that kind of code. So we write it one time. And that's what the transporter does. The load utility is one that might at first seem like you wouldn't need it. We're talking about bulk loading data. And most environments you have that you'll look at already have a bulk load tool. But the bulk load tool doesn't do all the things you need. It won't just sit there and continuously load. It won't talk to your audit tables. It won't do delta processing if you wanted to configure it for that. It may only support one kind of loading. So, for example, I work with DB2. Okay? And in the case of DB2, you have 2 bulk load utilities. One just issues SQL statements. Okay? It's great for concurrency, but it's pretty bad for performance. You can load 5,000 records a second, say. The other one, the load utility, works like Oracle's load utility. It basically dumps all the data into the file where your table is and then moves the pointer down. It runs 20 times faster. I can load on a big machine at 300,000 rows a second with that load utility. But it's not as good at concurrency. So frequently, you'll want to decide, I want this load utility for this table, this other load utility for this other table. You don't go with a low concurrency load utility for the little tiny table because you don't need the performance benefits and why take a risk on knocking somebody out. But you can write something like this in 1 or 2 weeks in a language like Python. Again, you shouldn't have to write it. If ETL wasn't so dominated by vendors, all this stuff would already be out there. So I think it will be out there eventually. Something like this might be the kind of thing, too, that you would write in 1 or 2 weeks. and then revisit a year later or a couple years later and make continuous improvements on it. Another utility that has to be written oftentimes is a publish utility. Because once you get all this data in one place, a lot of times people want a copy of it. And you've gone through all this work in transforming the data, you may want to just publish sets of integrated data, subsets to them. You could redirect the outputs of your transform. You really probably don't want them retransforming. Odds are they're going to come out with slightly different results than you will, no matter how hard you try to avoid that. So, so you end up oftentimes deciding to publish. And this is just a very, very simple utility. Again, 1 or 2 weeks, and now you're set. Deltas, as I talked about file image deltas before. So, what ends up happening is, in the simplest scenarios, you just pull an entire copy of data from some source system and dump the whole thing into your target analytical repository. Okay? The problem is, over time, it doesn't allow you to see history. You're just getting the current snapshot. So deltas do 2 things. They allow you to see the historical data, and they allow you to do that without just sticking a timestamp in and just multiplying all the data by every day or month. Okay, so now I don't have to worry about data explosions. I can take that feed of 1 million records. I can take it every 5 minutes if I want. There's no real error. And most of the time, I won't even get any records. Those every now and then when I do, boom, it's there. Almost no processing in order to handle something like that. The other way that we use deltas is sometimes to cut down the volume because it's so overwhelming. So what ends up happening is you can do deltas at the front of a batch process like this to cut the volume down to size, but you take a hit on data accuracy. The best place from a data quality perspective to do a delta is right before you mount. Because now you're copying this data, let's say the last file you received, but to what's actually in your target your destination repository right this moment. So that's where we like to do this. And also, while a lot of source systems have timestamps, you can't always totally trust them. Because timestamps may depend on applications running, triggers running. They may do a schema migration and use a load utility which doesn't do logging and doesn't update the timestamps. So timestamps are fine. We use them when we have to, but they're not as accurate as a file image delta. The only downside of the file image delta is if multiple changes have occurred between the 2 different snapshots you're comparing, you will miss that. So if you need transaction level changes, it's not always the best solution. Again, like all these utilities, 1 to 3 weeks, and that's done. So I want to show some simple Python. And my apologies if you guys thought we're going to do code reviews on lots of Python. I don't think there's time for that. But I want to show you a little bit of Python with some examples of what this kind of coding looks like. So this is a perfect example of what should be the simplest possible transform. All we're doing is we're transforming gender. Okay? How hard can that be? So this is a hypothetical example. But in this hypothetical example, we have 2 different systems with 2 different sets of gender codes, and we need to map them into our analytical environment. One system has codes like M and F for male and female. The other has male, female, transgender to male, transgender to female, intersex, transsexual. This is the kind of stuff we bump into, where we don't think how hard could time, for example, be. Well, it turns out time is really complicated. How hard could a simple gender code be? Oh, God, it could be a real pain in the butt. And so in this particular case, I have a Python function that I wrote that just translates all these into some other values. Okay? M, male, or 1, because maybe they changed their code and I have some old data. Or transgender to male, we've decided to relay to recode or reclassify as male. Here's all the different values. This is a very simple case study. I can show this to my business analysts. I can show this to my analysts, and they can read this. It's not complicated. Not only that, but I can generate documentation from doc strings right here. I can put all these transforms for a single feed all in one module, create one big document, and that's their documentation. And they're pretty much looking at the source code. And if they want to look at the exact source code, that's there too. So I think you can see that anybody mildly technical could read a simple transform. It's usually my objective to keep these kind of transforms as simple as possible for exactly that purpose. Because even in something as simple as this, which we see is not necessarily simple, they're going to come back. They're not going to be satisfied. New codes are going to emerge, or they're going to do some analysis and say, where the heck did unknown come from? And they'll have to refer to this. And this is one of the reasons why these kinds of systems are so maintenance intensive. Let's look at a more complex transformation. In this case, I cheated. So here, what we have is a little bit more of a real-life situation. We have some manually entered IP addresses, IP ranges, okay? And they are comma delimited and space delimited, and they are sometimes in Cedar notation, sometimes in dotted quad notation. And I need to explode that out to one row per IP. And so I might have a big list like this right here, and this might turn into thousands of records. Now it turns out that this is my whole function. This is why I have to admit I'm cheating. The first thing that I did was I imported a Python library called, I think it's IPPy or IPPDR, something like that. My apologies, I should remember that. This guy does a fabulous job of parsing and translating IP addresses from any code to any other code. This is now available to me. It would not have been available to me if I was using an ETL tool. But I did his code. And then I walked through and I created a module just to work with and analyze the data. Because I have to figure out what to do when sometimes in the same string it's comma delimited and then they use the space as a delimiter. Can I parse that? What am I going to do here? And now the great thing, because I use Python, is I've got a test framework for this. So if somebody says, how confident are you with what you're doing? Well, I'm very confident. Not only am I very confident, but if I make a change, I can retest it in 5 seconds. So this is exactly the kind of code that requires, the kind of problem that requires a custom coding solution. Python works fantastic for it. A couple other things I was going to mention on this problem is, I think that was my cold medicine, I'm sorry. So talking about this Python data movement once again. So now we're back at, we have our firewall data, we have multiple sets of reference data. I just cut it short here, so you want to overwhelm the simple diagram. Again, this is the kind of thing you write in an hour, put in a user documentation. All this is happening in the transform. Simple batch programs, because we've invested time in these utilities to make them as reusable as possible. In this particular example, I probably wouldn't actually take firewall data through a Delta utility, because that's actually an event stream. Deltas are more for reference data, but that's where it would happen. And there we are. So let me get to the bottom line here.
10 minutes.
Excellent. So the bottom line and my recommendations for Python is it's excellent for attracting and retaining your best developers. People like to write this code. Not everybody does. If somebody spent a lifetime working on Java, they might see this as setting their career sideways. And there are people who take a big view of data, and they really want to manage data. They want to work with ETL tools. But they seldom are the same people who you need for that complicated IP transformation. The second issue is, again, complexity. Any level of complexity we're going to hit refinement. No real cost other than hardware. So Python's not the fastest language. I could do all of this code faster in Java, far faster in C. But I'm processing and transforming over 200 billion rows every day. And I was doing that on an old used machine using Python. So when I talk to people who are transforming 1 billion records a day, which I've had to scope out and prepare for, I'm not having a problem with Python. So I can move to something like Hadoop, but maybe if I had to do 1 billion records in a half hour. But if I've got 1 billion records strewn across the day, I'm not having a problem with Python. Adaptability is excellent. We can, we can handle all kinds of different problems for it. And we have a great modern development environment. All the sexy, new, cool stuff going on is available to us. The biggest challenges that we have is that if you don't have an ETL tool, you're more at risk of designing an abomination. Because messaging systems, CRUD type systems, store procedure-based systems, they tend not to be manageable, and that's the main thing you're striving for. A lot of times people don't have, because we don't have a great body of work and literature on what the best practices are for batch processing here, there's a lot of risk when you do it yourself. And it takes a lot of, and if you don't have that rigid framework, it takes team discipline, because you can get really sloppy very easily. That's what I've got about Python here. On the tangent was Hadoop. We didn't talk about that. And that's really emerging in a lot of ETL conversations. But we didn't have to. There's a point where that conversation needs to happen, but I don't think it's quite here yet. That's what I have. Do you guys have any questions?
Could you do me a favor? Could you come up so we can hear the people who are watching live stream can hear your voice? I won't be able to hear you up there. Thank you.
So I'm not sure if you're storing the data, but are you using Pickle?
I'm not using Pickle very much. We can use, we wouldn't use Pickle for big objects because it's slow. But we sometimes use it for some temporary transient data. So it can be useful in that capacity. But most of the what we really try to strive for in this kind of batch operation is an ultimate commodity interface, and that is CSV data in a compressed tarball. And I can send that to any kind of downstream process in any language that it can handle.
So when it's in that form, you can decompress it readily whenever you have a request.
Exactly, and I can send it to a downstream process, and if for some reason we have to write that downstream process using some other tool, it could be another utility, maybe some other team says, look, we insist on using DataStage, which is a fine ETL tool, or Informatica. Not a problem. I can send them that compressed tarball, they can work with it. So we try to keep things as non-proprietary as much as possible when we're moving files between processes.
It's great. I like it.
Can I just make a comment on that? Oh. It's a one-liner, but I'll look up now. So in Hadoop, one of the cool things that you can do is actually read the compressed file. So you can just say, hey, there, I have a cbs.gz, and you say, load this file. And it will just load it, read it, and process it. Thanks. So you don't have to uncompress. Which, when with large files, that's a pain because you have to uncompress and run ETL on it, recompress.
Cool. Yeah, I can't do that. I'm working with DB2 in a parallel configuration. It doesn't support compressed files, but that's great. That's saving an enormous amount of time. A lot of times mine are tarballs, and so in my particular case, currently, sometimes I can work with it compressed, sometimes I can't. Python can also work with it compressed as well.
Yeah, and actually that's what I've done with Python, is I've actually used an archive, opened up a list of files in that archive, which is also gzip, and then read them, essentially took out the interesting rows, gzipped them on the fly, and then wrote down the files because I know how to do continuous transfer.
Nice.
So yeah, it's kind of
Anybody else?
Yeah. Can I ask a couple of questions?
Sure.
One of the things that we're finding in data science is very troubling is many of our data scientists are spending way too much time on cleaning the data, on data engineering issues. And so one of the things that I have found helpful is to separate those roles. And I often say data science is a team sport. So I don't want data scientists spending time on data engineering issues. I want to create a team that perhaps data architects, data modelers, data engineers, who will spend their time doing all of that dirty work, if you will, and having the data scientists spend most of the time solving the business or policy problems. Could you comment on that?
Sure. Yeah, I find that's a great trade-off because very few people I meet who are inspired mathematicians and who want to leap in and do cutting-edge visualization and really analyze data are satisfied spending a year writing ETL feeds. That's not the most exciting work. It is more interesting if you enjoy writing code in Python, or if you enjoy coding. If you're like myself, and in high school I always wanted to be a librarian. Okay, I love organizing things. So for me, it gives me just an odd, disproportionate amount of pleasure to organize all the data appropriately. So I'm not a data scientist. I am the guy who organizes the data. And so that's a natural kind of difference. I also find it's helpful to make sure that both groups get a chance to play each other's ground. So what ends up happening is I'm working with a colleague, a researcher at IBM right now, and he's learned Python. He's playing with Python and R and SPSS and Cognos in order to analyze data. He's transforming some of the data himself, so he can get to it, he can prototype things, but I'm not quite available. We're going to take whatever findings he has, and that's going to go into the analysis that's going to turn into a real feed. So that works out well. Likewise, we get to play with, when we get bored just moving data around, we get interesting ideas, things that we want to do with the data. And the same ETL process that we built for all this is what I built to do all of our scoring. So it kind of goes both ways, but there's definitely, we find most people have a preference for one role or the other.
Thank you.
It's very interesting. So I'm finding that you have so much data flowing in, to these feeds, and oftentimes you don't understand what the usefulness of the data is. And so you end up with a lot of useless data because my group, we do the data ETL and the processing of the data. So we're closer to understanding what it's going to be used for and what the people in management might want to see. So I'm wondering, are you actually looking at and scoring the data feeds, right, to find out, well, that's pretty useless, like nobody's using that in the downstream area. I'm just wondering, are you doing anything like that?
Yeah, personally, I find that big data analytical projects work best if they're in the business unit that's using the data. So this is one of the challenges, I think, for a lot of data warehousing projects is they become too corporate, and they end up getting staffed by people who really don't care about the mission and don't understand it, don't understand the terminology, and they don't do a great job, and they certainly don't bring any creativity to it. And yet they're up to their elbows and armpits in that data. They're seeing things that should be spread. So I really, really like, and that's the kind of role, I'm in a role similar to what your organization's at. I'm in the security and compliance group. And so I work with the folks directly coming up with ideas of what to do with the data. And I find that works best. I also find that frequently, I have to get data from groups that really don't want to give it to me. And so I will ask for the world, but I may only process 10% of it. I hope these guys don't hear this. Because I don't want to have to pull a bunch of data I don't understand yet, but I know I will never get a chance to go back. So if I miss something, I'm screwed.
Thank you. Any other questions? I have one. Sir, could you come up, please?
It's a really good question. Python you found that useful?
It was my plan originally that was a possibility because IBM's a big Java shop. Okay, and so Jython. So Jython is a Python interpreter that runs in the Java JVM. Okay, so that gives you the ability to integrate with Java objects and classes, and that was my plan because IBM's not really a Python shop, but it turned out it was not necessary. We had looked at it for performance reasons and for integrating with a lot more Java. The reality is to really become very competent with Java requires more of a career commitment than it takes with Python. So my Python developers on my project were wearing multiple hats. They were security analysts that learned Python on the side. Okay, I couldn't do that with Java. I could not hire Java people in the beginning of the project. Over time, we've changed that. Now everybody's pretty much a Python developer with interest in security. But so I think Jython there's a lot of interesting things going on with Python interpreters, and we're watching that. But at present, we're just using plain vanilla Python very easily.
All these data transforms we do, sometimes there's always going to be errors. I wonder if the metadata included on data is kept with the data ultimately. So in the event that certain processes are more likely to be error prone, that the data scientists can look at that data, and if they see confusing things about it, they can put less weight in it, regressions or whatever, and obviously.
Good question. So what ends up happening is it's kind of cost prohibitive to do too good of a job at that. So the main fact table in our data warehouse has 50 billion rows in it. Okay, we have a data quality dimension so that we can take that bitmap and explode out which fields have issues. But there's not enough, without really tearing up our capacity, there's not enough ability to go into the detail about what the issues were. We do have an audit trail, and that audit trail will give counts of what kind of business failures we have. And it's our standard to be able to say, it's not been perfectly enforced, but what greater compliance with this is our objective, is to be able to say any business rule validation will get a few records written to our exceptions table, which is a part of our audit, will be counted as a part of our audit trail, will be visible on our dashboard. And so that's how we really try to facilitate that. And one of the differences, to this point, one of the differences between managing data like this versus like unit testing and application is your application, once you've done a unit testing or testing, you're fine with it. In our case, every day we're getting different data. So it could work great for a year, and then today at noon the thing breaks, because it just seen data that violates every assumption we can give. So that's where really detailed auditing and keeping exception records is enormously helpful. But on the record itself, it's pretty expensive to keep any more than just a very tiny bit of info.
What did you go for? Pandas.
Why not?
Pandas. Do you think they are going to solve most of these problems?
No. So
The question was, what about pandas?
So Pandas is a great library for data analysis. In our case, we're doing data transformation, and Pandas could be used for part of that. But we have all these other things to do that aren't just a natural fit for Pandas. In fact, I would say that Pandas could be used as part of an ETL process. It becomes most useful if you're doing some very complex analysis and aggregation of a set of data. But if you're doing relatively straightforward business rules like the one I showed, none of those business rules are a good fit for a Pandas market-based application. But I would still keep Pandas in the wing as a possibility because there's certain kinds of things you could get into that Pandas would be really great. And we do, for example, sometimes rather than building aggregates in the database, we'll build it in the ETL layer. We save the repository in that effort.
I have one quick last question. Predictive analytics is really hot in data science right now. So Ken, I'm going to ask you to make a prediction. Considering all the unstructured and structured data, the explosion of new data, internal sources, external sources, what will the new modern data warehouse look like in 5 years?
I was just at the Hortonworks demo at the Big Data Meetup last week. And what I was surprised to discover is that it was actually all about data warehousing. Okay, all about data warehousing like 15 years ago. And so what we're seeing is that the data warehousing side, we've been looking at Hadoop since day one, focused on it. And the vendors have been trying to bolt on Hadoop and say they've got Hadoop since the very, very beginning. On the Hadoop side, we have not seen that same interest. And I'm going to ignore most of NoSQL for a moment, because most of that's just content management. It's not the same as what we're doing with stuff like Hive and Hadoop. But right now, Cloudera's got Impala, which is a parallel database just like DB2 or Teradata that sits on top of Hadoop. Hive is getting much faster and much better at being able to run star schema queries. It's still years behind the parallel databases that we have today. The performance isn't there yet, but it's moving in that direction. The thing that I saw, when I looked at Hortonworks objectives, the top 5 out of 6 use cases they're focusing on are traditional OLAP. They look exactly like data warehousing year 2000. That's what they're focusing on. The 6th was something that would be more unstructured data. Okay, so I think what's happening right now is that the Hadoop space is seeing that the big money is in structured data, and they are using all the terminology and the lessons. They're really trying to pull in as many as possible from data warehousing, and that's right where they're headed. That doesn't, we're still seeing a huge explosion of machine-generated data that fits in great in that world, and we're also seeing a lot of unstructured data. But right now, the emphasis for the next couple of years, I think, is on structured data and reinventing the data warehouse in Hadoop. And Kurt Monash and others have said they're not there yet, they're not mature. Give them 3 years and they will be.
Very good, thank you so much. We're going to have a quick 4-minute break while we switch. Yeah.
I'm not sure. You're gonna leave me alone and then
parallel processes. You guys are heavy.
See vendor connection to this we've there's definitely there's so much machine data. I was just pay attention to task force and just the amount of data coming out of same as the last page, it's gonna be stuff outside the operating, it's just amazing. It's just survey of all the researchers that they came back with the different ways that people restore data. I can't do that.
Yeah, I do. Mike, do you have a question that we can ask? Wrong cards. So is there a limit to how far you saw? Okay, everybody, we're going to start up again. Just a quick announcement. I really would love for as many people as possible to join us at Old Chicago after this event. I'd love a chance to meet and talk with you all. It is wonderful that we can have these expert speakers and learn so much, but also equally important is I really want the data science group to be a professional network, and so that we can meet different people, socialize, get to know one another. When anybody has a work challenge, I hope that you'd be able to call up your colleague in this group and say, listen, I'm having a rough time with this. Do you have any ideas on how to solve this challenge? So if you come to Old Chicago, you can meet people, you're going to be happier, you're going to be more successful in your career, and I'd really like to get to know each and every one of you. So without further ado, I'd like to introduce Donna Burbank. We're really, really lucky to have Donna. I'm going to learn so much from her presentation. Donna, thank you.
Okay, thank you. And this presentation is probably very different from the last one, which I learned a lot from. Probably a little more random and out there. But I know where this came from. So just full disclosure, I come from CA Technology. We make the CA Irwin data modeling product. So that's very much in the traditional relational world. So there's been a lot of talk already tonight about kind of the traditional relational or dimensional data warehouse, this new world of big data. And I know from our customers, the clients I work with, we're getting a lot of questions about big data. What's this new thing? Should I be paying attention? And I think as in any trend in the industry, we're great at buzzwords, we're great at hype, and there's always this prediction of things. I've heard things like relational databases are all going away. Everything will be big data. And then you hear the other extreme and some of the old school, relational people. Oh, it's bad. These big data people are just childish. They don't know all the fundamentals that we do from the 1960s. So the truth is somewhere in the middle. So I traditionally give this presentation to more of the data architect crowd, the more relational crowd, but I know it's more of a mix here. So I'm definitely open to discussion. And maybe I generate more questions and answers in the presentation, which may be why it's a little different than the factual one you saw earlier. That's the way my brain works. It's kind of all over the place, and I usually am all over the place, so I apologize. I don't sit still well. A little more who am I? So I started out my career as a data architect, data modeler. I did data warehousing, metadata management, talk about liking to organize things. I could have been a librarian too. A certain mindset. It's a good thing, I think, but it is a thing. We're a little different. So I worked for many years at a company called Platinum Technology, if you remember way back, showing my age, both here, and then I spent many years in Europe running their Center of Excellence for data warehousing. Then kind of moved to the back side, more direct product management, product development, and now into more product marketing. I'll let that title fully. I'm still a geek at heart, and I use the word geek lovingly, so no offense there. I recently co-authored 2 books. Anyone here know the name Steve Huberman? Good name to know if you are into data modeling in the relational world. He does basically data modeling. He's the data modeling. Someone was asking who's the data modeling guy. There's a lot of data modeling people out there, but he specializes in training data modeling how-to. So we put together the first book, which we are giving away a copy of tonight. One lucky winner. I think he's going to come up with some pithy question from something. So it's the burdens on him of pushing it around. And that really is, and there was some talk about it, I really like the presentation. There's got to be some synergy between the one previously of sort of how to get the attention of the business. So we can do all this technical stuff in the back end, but what does it really mean to the business, and how do you really get those business roles? So if you're a technical data person, you might feel it's kind of light, but that's the purpose. It's kind of try to take data, make it a little more accessible to the masses, I guess. The second one is more traditional. It's data modeling made simple, specifically with the product Irwin, but it does go through, again, if you're new to data modeling, all the relational theory, third normal form, star schemas, all of that, and then specifically how to apply it with Irwin. But then I won't talk about product anymore. That's not why we're here. And I'm also, just another plug, I'm a board member, oops, I shut off my own presentation, of the, really smart, too. Of the DAMA Rocky Mountain chapter. Anyone here a member of DAMA, or heard of DAMA? Couple? So I'm very excited. In fact, Michael's been trying to get me here for months now, usually in another country somewhere. I do a lot of work with DAMA, with other groups, speaking internationally, and I'm very excited because we finally have a DAMA group here in the Denver area, which we have not for a long time. So it's just starting up. So it's a data management professionals organization. So probably a little more of the focus on the data warehousing side, but more of a focus towards data science. So it might be something to look up with LinkedIn group, or give me a call. So that's me. So I can't talk to each one of you, and I know this is kind of a diverse crowd. So if you have to just describe your role, and I might not fit everybody here, but who would classify themselves as a data scientist? Okay, got a couple, 2, 4, 5. Who's more a traditional data architect, data modeler, data warehousing person? About the same amount. Who's maybe a business analyst? You're on the business side. Got a few. Looks good for you. Who is a DBA? I know this is like a weird mix. A DBA programmer, networker. Okay, a lot of those folks. Combination of everything. You get a lot of those hands. Other. Did I miss something? What's some of the other? I don't want to.
Lecturer.
A lecturer. Okay.
I'm a computer modeler. I'm just going to be for construction and architecture.
Okay. Anyone else?
I'm a web developer, so.
Okay, I put you here. Other no. Okay, that helps because it is a broad mix. Again, as I mentioned, I generally see if I can use the pointer this time. Shut up. I usually talk to this crowd, and that's kind of my background, or this crowd, It's kind of where we sit. Not so much.
What the data scientists do.
I am not going to touch that one.
If you want, I'll handle that. I think we're in the pre-industrial age of data science, and it's evolving, and one of the exciting things for me is that we get to evolve with it and define it. So I define data science as the scientific study of the creation, manipulation, and transformation of data.
That's very broad.
I think we could be here all night with that. I have a slide. For a business, I think it was touched on in the previous presentation, for a business that we're supposed to define data, we're really bad at definitions ourselves. As I have a slide, I'm really talking, what does modeling mean? Like for me, that means third normal form, boxes and lines. To a data scientist, it might be a financial model.
I think the data scientist uses scientific methods to get meaning from data. That means solving a business problem or a policy problem or a research problem. So in reality, a data scientist solves problems, innovates by using the scientific method of data. And that's what we see data scientists doing. So, yeah.
I definitely see it's an evolving field. That's why I don't want to get too far afield. I think we get a whole topic, a whole session on that. My little version of it. I tend to see data scientists come up more in the big data realm, where it's more programmatic, less the analysis of the data architecture, which is more traditional, and more of this kind of big data world. One more comment, then we're going to
I just wanted to add a data point to what's being said. In terms of data science, it is very much new. RPI, which is one of the leaders in academia around data, they just have last week announced a new institute, $100 million going into data science, essentially. So it is still a new field being defined.
Yeah, so if you look here in the comments, just another reiteration, this is definitely a new field. So that was kind of a summary. And then again, so that's kind of the distinction I'll make in this. We could go all night. Data scientists think more of the big data realm. Data architect, data modeler, I'm thinking more traditional. In this presentation, we'll kind of talk what's the difference between those, are they merging, that kind of thing. I've never had that much discussion on my introductory slides. I remember that we are all different thinkers. So. Okay, so this is kind of a trend. So again, I work a lot with the data architect, data modeling group. Dataversity is a good resource to research if you're into data, which I think we all are. So basically, it's an online university for data. So they have a lot of speakers, topics, white papers. So this one was a survey they did last year, 2012, for data modelers, kind of that traditional data architect. Again, we're hearing the buzz on big data. It's from the data architecture crowd. A lot of it's, I'm hearing about this. How does it apply to me? So the survey was how much of an effect is it? What you're seeing is right now, and then this is validating the conversations I have with the customers I talk to. Right now, it's sort of either I don't know what it is, or I'm starting to hear about it, or I know it's going to come, but by 2020, it's going to be a big deal. So a lot of it's in the educational stage. And back to the previous slide, but I'm not back to the previous slide because I gotta get home. No, I'm kidding. There do seem to be camps, and it was touched on in the last presentation. It's like there's the data science group, and they're over here, and then there's data architect and the programmers, and never the three shall meet. You know, we have these silos in IT, and I found I don't think these groups are talking. Partly it's technology, partly it's culture. So right now there is a disconnect where I think in the traditional world it's I hear these words like Hadoop and it seems really cool, but I'm hearing so much buzz I'm not sure what it is. So, but it's coming and it's out there. So, okay, well what the heck does this have to do with big data? But as I told you, I digress. So that's why I didn't want to digress too far on the first slide because we'll be doing a lot more digression in this presentation. So I live up at a cabin. We live in Colorado here, right? And I think weird things. I have a lot of time to think. So as I'm thinking of big data, to me it's a major paradigm shift, not only in data, but in our society. And so I was trying to draw some analogies. So the first one was the telephone. So you think, I was not around, I'm old enough, I was not around this phase, where you actually have to make a telephone call, and you're in a small town, you actually have to go to the switchboard operator and make a telephone call. That was a very centralized view of communication, right? I have to go, she may listen into my call, maybe not. I tended to schedule those calls, right? If I'm going to make a call, it was a big deal, it's fairly expensive. Maybe somebody got married, we're going to call grandma, you talk for a few minutes on the phone. Then, you know, come later, it was, hey, everybody had a cell phone in their house. That was a pretty big deal. But still, there were parameters, right? It was scheduled. I still remember when you'd call after 6 because rates went down, or call on the weekend. So, still very limited, but a little more distributed. We got things a little faster. I do remember these days where you finally had a phone you could touch dial, and I'd have to do the little rotary. And then things became not only more distributed, but didn't even, I remember walking around the house with a phone. That was a pretty big deal. You weren't attached to anything. But then you see some changes here. Not only is the volume of change increasing exponentially. So, from here to here was a little more convenient. It took some years. Now it's the, iPhone du jour. You have the iPad X. That was still last week. I can't believe we don't have the new. So not only is it the volume of change, but what else has changed? It's very distributed. Right, I don't have to go to a central source. I don't have to schedule it. You think of the younger generation, I want it now. And the other big change is I want to be interactive. Right, the old school is very passive. I choose to make a call. I say something. It's transacted. Here, not only is it voice now, but it's commenting and chatting and linking with something else. Who's on Facebook, and then what are they listening to on iTunes, etc. So it's very integrated in the rate of change. So it's completely digressed from everything. Again, everything in my life relates to data because I am a big nerd. I use that lovingly. Geek and nerd, good things. So I live here in Colorado. I have a niece that lives in Boston. She comes out each year to visit. And she came several years ago. She was about 16. She had her first boyfriend. It was a big deal that she was far away, and they're at my house with wireless, and they're texting back and forth. I'm feeling pretty. Hey, I'm not from this school, right? Where you get a phone call, it's like, Mom, shut up, and you run to the room, and you close the door, and you're hoping they don't listen in because it's one line. So it was a big deal to get a phone call, especially to my niece. And this was very expensive to call international. Like, hey, I have international dialing, you can just call. I mean, it's free. You can call anytime, really, it's no big deal. I think I was all, worldly. She could call boyfriend, I'll go outside, privacy. So she calls him, hey, dude, I'm online. And he hangs up, and they start texting back and forth. And I'm like, okay, that is just weird. But that is the new generation, right? Everything's tech. So in my brain, not only was that weird culturally, no offense to my niece, I've told her I use her in all my presentations, she's okay with it, but now she'll see it on YouTube. But in my mind, I'm thinking of all the massive parallel processing and Hadoop clusters or whatever to send this data back and forth. It's, dude, what's up? Nothing. Bored. You. I mean, there might be little gems of information in there, but basically it's a bunch of garbage. And I'm thinking all of this back and that's my brain. As I said, it wasn't quite normal. So, but this will link back to big data, I promise. So then I got another thought. In the old days, I'm still here. I grew up in this age where you actually write a letter with your hand. Who does that? I actually had a pen pal in England. And my mother, if you hear me in other presentations, my poor mother's in my presentations on YouTube too. I have family issues, I guess. She was a teacher. So she, we would go on I grew up in Boston, so we'd go to Plymouth Plantation or something. And most kids, in school had to say, what did you do for your summer vacation? We had to write these letters every time we went somewhere. What did I learn at Plymouth Plantation? And you'd rewrite it. And so, victim of being a teacher's childhood teacher. But so we had this pen pal with my cousin over in England, and I would write it out on yellow paper, and she would correct it, and then we'd write it on nice paper and send it, put a stamp. It was a big deal. You really had to plan what you were going to say, and you had to write it out, you make sure it was right. So very much a top-down design in my computer world, and you didn't do it very often, because I hated it. In fact, I've been to England about 17 million times and never looked up at this cousin. I think we were both traumatized by it. She's probably a lovely woman, but no. So then I remember when, hey, we could do email, put a stamp. Whenever I feel like doing it, you send the email, you get the information. And then as things progress, hey, I can see it visually on the web. But again, similar to the phone, because as we know, these are melding. The difference between a phone and a tablet and the internet. So what has changed? Not only the volume have changed, again, from letters to computer was hundreds of thousands of years, right? And now it's the device du jour. So again, it's more interactive, it's more rapid, it's more interconnected, and it's definitely not passive. And it's more random in a way. So how does that relate to why I'm here? It does. So in my mind, it really does have some parallels with how IT has changed, or how computers have changed. So if you think in the old days, you had the mainframes, right? Definitely is kind of a top-down waterfall design. So I wanted to run a job, I had scheduled it. I think of the switchboard operator, right? I don't just willy-nilly update something. I have to think about it, process it. So it's definitely a design and build mentality. a lot of the development was done in-house, right? And it went on for a while. When you think, again, as things progress, this idea of having your own PC was a pretty big deal. The distributed development, relational databases that we'll talk about, really the democratization of computing. You don't have this big central mainframe in the sky that you schedule. And again, you'll see the change is not only more rapid, but there's some themes. So more distributed. I think when we had the dot-com revolution, everything was going rapid development. It kind of burst. And I think this is my commentary, color commentary. I think it's going to get a little boring in data management for a while after that. A lot of it was data integration, the ETL stuff we were talking about. How do we take all that mess we created and make sense of it? I think we're still there. But a lot of it in that era was kind of how do we do more with less? How do we figure out what our data does? It wasn't as fun. Now I think it's fun. Things are changing more. We have this big data. I won't talk about data vaults here, or agile, where some of the themes, it's more rapid development, it's more democratic. You know, the whole idea of agile is that it's less top-down waterfall and more discovery, right? Things just sort of emerge through team building, through rapid change. I don't stop, design, and build. I do rapid iterations and discover as I go, and have much more, talk about more democratic. That really is a lot of the theme behind agile. So a lot of change that really parallels the changes in our society, that more of a democratization, the more interconnectedness, the more I own the data I have. So again, I see this as really a paradigm shift in what we're seeing. So the traditional is that top-down hierarchy. I'm going to think about the letter and then write it out and send it. I'm going to design my program and my test cases and implement it, and do that in stages. And again, a lot of these are quotations. You know, if you think of passive push technology, in the old days, I'd have a website. That was exciting. I can look up something on the web. Now, if you can't update it and add a comment, like it on Facebook, or share it, it's not so interesting. People want to have that interactive experience. And a lot of these I put in definite quotes. Manageable volumes of information. If you told us in the 90s we didn't have that much data, we would have laughed. Yeah, you have terabytes. This is huge. You don't understand. And yeah, stable rate of change. We thought things were happening really fast then, but now it's exponential. So kind of the paradigm switch is really more to this distributed democratic real-time analysis. Not so much design and build, but discover as we go. Much more collaborative and interactive. And again, we thought we had a lot of data. Now it truly is massive, and I'm sure we'll give a similar presentation in 5 years and scoff at ourselves for thinking we had a lot now, right? It's only going to get worse. And the big change here, I think, from, and it was touched on in the last presentation, from data warehousing and business intelligence, where a lot of it is you design it, then implement. I'm going to build my start schemas. I'm going to define, I need customer data and product data, and I'm going to build a warehouse to define, to answer these predefined queries, to more of analytics. And I'm not going to talk about this, but to me that's a bit of a difference between a data scientist and a data architect. Architect is more on this side, or data modeler. I see the scientists more on this side. And it's really putting it on its head when you discover, and then maybe if we're not quite there, then you document, right? So what patterns are out there that I might not have thought of? And that's what's exciting about big data, is seeing these correlations, seeing the analysis. I was on a radio panel. DM Radio is another, there is a radio program just for data out there. It's online. I know, who would have thought? Geeks Unite. And we had a whole conversation on this change, and a lot of it really is philosophical of, you know, if you view the words and I know exactly what I want, you're missing stuff. So it's kind of opening up and saying, maybe there's patterns I hadn't thought of to put in the data warehouse. Okay, another diversion, but not. And really, I think, again, the way we look at the world as a society has changed. So if you remember from school, and I do, I'm memorizing like 4th grade, kingdom, phylum, class, order, family, genus, species. Linnaeus, back in the 1700s, established this hierarchy, this taxonomy for organizing nature. And I'm not going to touch on religion here, but that kind of was the idea. We had this top-down design of nature, and if we could just organize and discover it. For those of you who aren't in the room, there's a periodic table of the elements on the wall here. Very similar. There are these patterns in nature, and we just unlock and figure it out. Now everything can be organized into this pattern. So this was exciting that every animal we find can be, or plant, can be classified here. So very top down, very organized. The librarians in the room love this because we can put everything in a little box. And there's a place for this. This is very good. But as I like to do reading and this type of thing, I think about this, really the way we look at the world has changed. There's things like chaos theory that we're looking at, where really is this design where everything's nice and ordered, or is that our brain imposing that upon something that doesn't exist? So there's this theory called emergence, which kind of putting poor Linnaeus kind of flipping his way of thinking things. So think of the idea of a snowflake, where there's definitely patterns of a snowflake. But as they say, no two snowflakes are the same, right? But there is this concept of snowflakeness that sort of emerges from these random patterns and creates pattern out of chaos. Apologies for folks who are experts in emergence. I'm doing my version of it. So if you look at the definition here in philosophy, it's complex systems and patterns arise out of these interactions, so chaos, order out of chaos. I also find it interesting that I took the definition out of Wikipedia. So again, if you're thinking of a chain before it was the Encyclopedia Britannica, where bearded guys in a room decided these are the rules and this is what it is. And then this idea of Wikipedia where all the unwashed masters are going to give definitions and it's going to be chaos. And I'm not here to say pro or con Wikipedia, but generally this is good stuff. It may not be perfect, maybe the encyclopedia wasn't either. So I think, and I will admit, I'm definitely more, like personality-wise, I'm opening up to YouTube here. In this case, if you look at my desk, it's organized. I like my checkbook is balanced. I like to put things in this little place. I think, as the previous speaker mentioned, this type of person tends to go into data architecture. So it's really bothered me. Thinking of these things, I like that it's not orderly. But I have to admit, I go to Wikipedia a lot. Tends to be organized, right? Or I do a Google search. That bothers me. Who has a structure behind Google? But it tends to kind of, over time, between rapid change of correction, it tends to work itself out. Yeah, there was a question.
We talked about in this closed world versus open world. Does that come up in data architecture domain or data architecture domain, like relational databases being closed world assumption versus the semantic web and the big data being open world assumption?
Yeah, so the context.
Could you repeat the question, please?
The comment was, does this kind of relate to we have closed world versus open world? And I think very much so. Whereas when we look at things like the semantic web, that's definitely more open world. And things like data quality that were touched on earlier come up. I think if you have an accounting system, and you definitely want to know, or have a data warehouse for my financial system, want that to be a closed system, right? I want to know X, Y, and Z. If I'm trying to discover patterns of customer interaction, maybe the quality doesn't have to be 100%. It could be good enough. And it is kind of finding a fit for purpose. And I'll kind of, again, I ramble, but I will kind of wrap that up at the end of just make sure you're using the right tool for the right job. Because both of these have their place. Linnaeus is a smart guy. I'm not going to put him down. But I think we're learning something here too. And as a culture, I don't think we've worked it all out, right? We're still learning. But just to continue on Emergence, some other more practical, these snowflakes are cool, but they use that in city design. So, think of a traditional city as square grids, right? If I think back to my university, all of the pathways were square grids. And when you want to walk somewhere, you go the most direct way. Finally, they gave up and just paved the way everyone was going to walk. And that's kind of this idea of using emergence for city design. They look at traffic patterns and discover patterns and then build road systems based on traffic patterns. So again, it's discover, then implement rather than top-down design into a grid. So I relate that to things like big data where I'm trying to do, social media analysis of I might be a jeans company, and I want to know what are people saying about Levi's jeans. So someone could, on Facebook could be saying, I love it. It could be my niece talking to her boyfriend, I love my new Levi's jeans I just bought. That's relevant. I want to see that. Or is Levi coming to the party? That's a person's name. Not relevant. Twitter hashtag is a sale at Levi's. If I'm Levi's, I want to know that they're discounting me 20%. Or it could be a typo, LOL, TTYL, leaving soon. That's a typo. So there are gems in there, kind of like that conversation with my niece. A lot of it's dumb. Sorry, niece. But there are gems of information. So, relational databases versus big data. And being that there's some big data experts in the room, I won't go deep here. But really, this idea of big data is with this rise of massive volumes, this real-time information, these traditional relational database technologies don't scale. So we're thinking here, again, it's not a lot of data. Again, we've had a lot of data for a long time. It's these massive, and all the velocity, the volume that I'm sure you've heard of. Just things like Google, Yahoo, Facebook. There's some of the founders of this big data. You know, I'm trying to find information. I don't say select star from Google. First of all, it takes several millennia to get back, and it's just not structured that way. So it's things for like the example before, the email logs, clickstream analysis. Some of the issues that arise, you're not going to just store that in a single relational database. You know, as was mentioned before, some of the relational database vendors are again, the world's emerging a bit, but in general, it's too big to just plop into an Oracle database. You can't necessarily index it, it is too big. It's not, and then again, write structured query language on it because it is by nature unstructured, a lot of it. And it's not like you design data structures top down. It's always in flux and creation, so it's more of a discovery process. A lot of the big data solutions, I don't know we talk to do, there's a lot of different big data solutions, but some commonality is divide and conquer, right? So and when I talked earlier about this distributed nature of IT, a lot of the solution of big data is to divide the work across servers, store the data in files rather than a relational database. It's post-creation, real-time, you should structure it as you access. Again, it's not this top-down design. And it's more of a programmatic application level processing. So you're doing hashtags, hash tables, you're pulling the records. It's not like within a relational database, you structure the data to query it. Here it's more programmatically designed. But the business problem is the same, right? So you have the business person saying something, you know, this seems really simple to them, right? Can you tell me what our customers are saying about our product? Hey, can I have it by this afternoon? How hard is that? There's that big data stuff, right? Press the button, gets it back. Shouldn't be that hard. But we know this is extremely hard, right? We've been working on this for decades. Even if you have something simple like how many customers do I have? We're still not there even in the traditional relational world. So for those of you who are in the architect or DBA, would get this. So one of the problems, even if we're just looking internally, okay, which customer database do you want me to pull this from? We got to put 25. A SQL Server, DB2, and flat file that someone had after they retired. So just organizing that whole conversation earlier, ETL. How do I get a single store of all my customer information? And then the data architect chimes in, oh yeah, by the way, all of those 25 databases, even something as simple as customer name is stored differently on each platform. There's different character lanes. And you could get even more detail here. What do you mean by name? Is it surname, first name, last name? In different countries, the surname means something different. I mean, data architects are in their keep just trying to figure out this mess, right? That's hard enough. And then add things like, what are people saying about my product on Twitter? Or these big data sources that are trying to get to the mix. So that is the challenge. That's the opportunity. We never had that before to be able to look at that clickstream analysis. But I don't think we're there yet, getting that answer by noon for the business sponsor. But that is a lot of the use case of, I do want to know more about my customer information. So I'm sure if you've heard big data, you've heard the V's, right? So 3 V's or 4. Who's heard of 3 V's of big data? Who's heard of 4 V's of big data? 5. 5? Heard 5?
I can't remember what the it's not like 60.
Everyone has a different V, so I'll talk about some V's here. So typically you hear volume, velocity, variety. And that's kind of what we're talking about. Not only is it massive volume, it's changing at an exponential rapid pace. Clickstream data or log data or Twitter feeds. And variety. It's not nicely all stored in a relational database anymore. It's everything. The 4th V that I'm hearing more frequently is this idea of value. It's kind of fun that we think of this last in IT. We sort of often get so excited about the technology. What does it do? I don't know. Check out the script. What's your 4th V?
Veracity.
Veracity. That's true. I didn't even mean to. Back myself up. Yeah, I think veracity to me would be similar to value, but it's not only why are we getting this, but is it right once we get it? So I guess they're linked. So now we have 5. Here in Denver, we have created the 5th V, and it's documented on YouTube. But often we forget this, why are we analyzing? What is this, the value to the business, and what aspects of this volume are worth keeping? We have tools now to analyze everything. I mean, there are some great tools out there, let's use them wisely, I guess is the point. So, one of the things to filter in this case, there's a lot of stuff about Levi out there, what's relevant, what do we want to keep, and what can we learn from that, maybe put that into a traditional data warehouse. This is a cartoon. Yes, there's a data modeling book with cartoons in it, and he's going to think of a great question that someone has to answer to get the book. But this is a cartoon from the book we were giving away today, and it's not that funny. It's data. But this might have happened to you. We're all done with this project. We built a whole marketing application about it. Oh, one more question. What do we mean by customer? Which might not seem funny if you haven't done this. I remember when I first was in IT, I'd go to these conferences and people were like, yeah, we're trying to get a single view of customer. What's so funny? How hard is it to get a definition of customer? But as you know, there's a lot of different, we're talking online customer, retail customers, historical customers that might have been with our company and left. So many different variations of, if you're a software company, are they on maintenance? A lot of different definitions. If you get that wrong, sales might be, I was working for a large company that said, could you give me a list of all my customers? Sales doesn't want to go visit a customer, right? They were prospects, they didn't own the product. Gave a really embarrassing report to the CEO, just because they didn't have the definition of a customer, right? So people, the uninitiated who haven't been through this think it's really strange. How hard is that? Once you've been through that, you realize this is really hard. And that problem doesn't go away just because it's on the news, right? So I've heard that I mentioned at the beginning extremes. Relational databases are going away. The world we want to do, and I all the different versions of that. So do they go away? No. I think I would say no. At least not in the near future. They're good for what they're good for, though, right? So what relational databases are good for is I will say what they've always been good for, right? The things that they came in. So if you are designing a database that can be designed up front with your predictable queries, how many customers do I have in the Northeast region who bought a product last month? That type of stuff is great for a relational database. The things relational databases are good for, I want to retrieve things with an easy query. I want to reduce redundancy, that good old third normal form, right? Or fourth or voice cod was there for a reason, right? You don't want redundant data. Again, if I'm using my accounting system, I probably want it on something like relational database. So yeah, same reasons you always use relational databases are still valid. What big data solutions are good for is you're analyzing those large volumes of unstructured data that are updated in real time. Finding correlations between data from multiple sources. That's what relational databases are not good at, seeing that correlation of the patterns. If you know the answer to the question before you start, think relational database. You're trying to find correlations, patterns. Big data is good for that. And often, and I'll talk about some use cases, it's analyzing this real-time data before you might put it in more of a traditional data warehouse. So they can work very well together. It's not an either-or. I've been joking that there's these camps and these silos and teasing each one, and don't get offended because I tease myself. You've seen that, so I do that. No offense. But there really shouldn't be camps or factions or one is better than the other. It's a fit-for-purpose solution. So one way I've seen work together very nicely is you do some of this big data analysis. What are folks saying? Maybe it goes into more of a traditional customer sentiment data warehouse where you have things. This is what gets my goosebumps going, right? I can do a nice relational database. Is an interaction with a customer, is a complaint, a question, a compliment. These things you can design and have structured queries around. So some case studies who are using big data, relational data, and kind of several of the different extremes. So ARTS is an association for retail technology standards. So they set standards for lots of different technologies for your large retailers, Costco, Walmart, your large retail organizations. You can look them up online. So I will plug, they did just standardize Irwin, but they use a traditional relational data model, I guess, data warehouse, so, who want to understand and let their customer information. So they are looking at big data analytics, but then they analyze that before it goes into the structured data warehouse environment. So they do have their traditional structured data warehouse for 95% of the stuff they know. But and it is right now, it's a separate team. And they work together, and so these new things they discover, if they feel it's relevant, maybe something like Twitter hashtag for a customer. We didn't even have that before. Maybe now that's relevant. Maybe we should put that into a data warehouse. So that's how they're working those two together. So it's kind of doing the discovery of your big data, picking out what's relevant, putting that more to the traditional data warehouse. Disney Intranet is sort of another extreme. So a colleague of mine, Matt Estes, did this presentation, a little bit outdated now, but still relevant. But they speak very frequently at things like the Duke World. This is one presentation you can find on the internet, so I'm not stealing it, Matt, since you had it up there. And they've done a lot more recent, so they've been very vocal. And so they actually moved from their traditional data warehouse, your traditional relational, and then your ETL process and store your data warehouse, to their data warehouse actually stored on the Hadoop infrastructure with HDFS. So when you think about it, this is Disney Internet. So it's things like Disney and ESPN and all of their websites, and they're trying to do clickstream analysis. So this really is big volumes of data. So I think back in 2011, it was 10 to 12 billion page views, right? So that really is a big data problem. So many organizations don't have this volume, velocity, variety for their traditional data warehouse, but they did. So I think they're very much ahead of the curve and actually moving all of their data warehouse to the big data environment. The next mix, so we have one using traditional data warehouse, which was ours, kind of taking pieces of big data and putting it in. We have another, which is Disney Internet, actually moving everything to big data. The third one.
So if Disney moved to this model, right, where they're realizing this vast volume of data that they're using or able to use a tool like Irwin to really try to model that.
So the question was, for someone using everything in the big data, do they use a data modeling tool? No, but we're talking to them. And then my last slide, I don't think any of the data modeling tools out there have gotten this right. And I'd love to brainstorm with people after what that might even mean. So I will kind of talk about that is a data model even relevant in this new world of big data? So the third one in particular, as I said, I'm not in camps, but I am, one is better than the other, but I do come from the traditional camp. So you kind of want it, deep down, I kind of want to say there's all these cool new technologies, but if they just listened to us who've been doing this for 20 years, they would have known that they have to get their data types right, and they should have done the data model first, and all of that. So this next one did make me happy, although I will contradict my happiness in a moment. So Facebook was a particularly good case, good study I liked. So I would recommend looking at their video, which is online, the TWI Chicago from May. It is out on YouTube. So Ken Rudin, the director of analytics at Facebook, did a great presentation. So as you know, Facebook is one of the founders of big data, right? Their whole system runs on big data. They are the traditional big data problem, right? I'm trying to see who is friends with who and who's clicking on what. Those are the correlations I'm trying to understand. But at the end of the day, they realized that that's great for that use case, but when I wanted to find out some basic questions, like how many customers do I have, I need to go back to the old school data warehouse. That's the best fit for purpose for that. So he knew he was making sort of a statement when he goes to the data warehouse institute and says, yep, we're going to build a data warehouse, because there is kind of these camps. But I thought it was great, his presentation was great in kind of explaining this great fit for purpose solution. So his example is he needed that single source of truth for your core business data. So, for data warehousing folks, these terms are familiar, managed chaos, single version of the truth. And what's key here is, and I touched on this in previous slides, just to find those core elements of the business and leave the rest alone, right? There's a lot of data out there in big data, but what are the core pieces that we need to manage in a warehouse? His example is that there are hundreds of thousands of tables in Hadoop, just down to a few dozen in the data warehouse, right? Just what are these core elements I need to care about for this particular use case? So what this data warehouse was good at, again, it's fit for purpose. So if I'm going to do typical operational analysis, how many users are logged in right now in the New York region? That's a traditional data warehouse question, right? If I want to do more exploratory, then he was saying for that type of query, it was a minute on a data warehouse over an hour to do, right? So one is faster than the other, they're good at what they're good at, right? So he found he actually had faster performance than the traditional data warehouse. What big data was good at is this more exploratory analysis. Kind of makes me nervous. You know, where are users posting from? If they say I'm logged in from New York, I know I'm from New York. But what if they didn't put a location? Can we infer one from other things they might have posted? Kind of seeing correlations between other information. That's what big data is good at. And I like this quote he used because they stole it from me. I've been saying this for a long time, and they finally listened. But now I've been touching on this. This is from Jim Collins, author of Good to Great, popular book if you haven't read it. You know, the genius of and and the tyranny of or. I think we tend to do that. It's one or the other, an exclusive or. Right? It's either big data or it's relational. He made a very good point of saying, you can have both, right? There's a fit-for-purpose solution. This is one of the founders of big data technologies, or early adopters, that is also using a data warehouse. They're still using they're still using big data technology, but for this particular use case, a data warehouse was better. And then this part, I have to say, didn't get me my little skin crawling. This was my I told you so moment, I have to say. He found the biggest challenge in all of this was trying to get some of these business definitions and the business value of data, right? So his example was, I want to find out how many users were logged in yesterday. Well, data architect comes in, what do you mean by a user? I love that he said this, wasn't a data architect having to come in, did you think through this? Things you might not have thought, how hard is it? My earlier point, how hard is it? What is a user? Pretty obvious, right? Well, what if I'm not logged in on Facebook, my laptop, I'm on a mobile device? Is that still a Facebook user? Well, probably. But what if I'm posting something from Spotify and I'm not even logged into Facebook? Am I technically a user at that point or not? So those are the kind of questions they need to answer to get their simple question of how many users do I have logged in a particular region? Sound familiar, right? We have our basic definition of customer. Doesn't matter whether you're one of the biggest companies using big data or not, there's still core principles to apply. You can't forget the hard stuff, which gets back to that, not only the volume, velocity, variety, but the value and the veracity of that as well. So, someone asked the question earlier, can you do a data model from that? This big data stuff, I don't think we're there yet, but at CU Technologies, we are doing a lot of research. We've done some, we're partnering with several universities in China and have published some work on this, because nobody's there yet. So what I do think we have pretty well as an industry is this part on the left. So the data model, the business book talks a lot about how you have this conceptual or this business view of information. Here's where I say, what do I mean by customer? What is a product? What is a user? That stuff, right? So that's generic of any technology, a user to user, whether I'm using Hadoop or SQL Server or DB2. What we tend to do in the relational world is break that into a logical data model, which is still your business view, but and I know I'm not going to get into this argument either, generally your goal is to put this onto a relational database. So you're doing things like primary keys and foreign keys and data types. But you're still looking to get to a relational database, whether it's Teradata, DB2, SQL Server, etc. Pretty well standardized in the industry that most data modeling tools do this. What I hear a lot of our customers ask me for, again, that picture of the guy saying, show me out what my customers are saying. The business wants to see this and then drill down regardless of what it is. But the problem is, traditional logical data, well, there are things like Hive that can do kind of SQL-like things on top of big data. But at its core, depending on which big data platform is, a file-based or a key-value pair, what does a data model look like for that? And is it even relevant? Because kind of the idea of a big data implementation is that you may not log ahead of time, but you want to discover and then analyze. So this is some of the research we're doing of having this idea of a conceptual data model that could then link into these different technologies. And then, and this was actually suggested by Matt at Disney, we have this idea of mixed notation. So I have these things, or these core elements.